So, I have a little program here. It's not too big, but and it's the start of something big. But what I have here is a display list interrupt program. No, it's not interrupt yet. All it is it's showing you the display list in hexadecimal form for all the modes. So if I run this, ask for what graphics mode. So let's start at the beginning with graphics mode 0. And we hit the space bar, and up comes the display list. So we got 70, 70, 70. What that does, each 70 skips 8 scan lines of no signal. So you get black for 8 lines, black for 8 lines, black for 8 lines. And then we have a 42. The 4 means to load the memory scan counter. And the address is 9C40. So if we let's do something to cause an error. There we go. So up here got 70, 70, 70. That's 8 lines of black for 24 lines. And then this 4 here, this 4 right here, means load the memory scan counter. And then we have a 2, which is actually antic mode for basic mode 0 is 2. And then here's the low byte. This is hexadecimal, remember. So 40 actually means 4 times 16, which is 64. So that's the memory scan counter is reset to 9C40. And then we have what? So that was 1 line of mode 2, antic mode 2, 2 lines of antic mode 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 lines of mode 0, which is what you're looking at. And then we have a 41. That one, that numbered together, the 65 is what it is, jumps to the beginning of the display list and waits for the vertical refresh. And then we have the value 9C20. And you can see that same address up here, 9C20. So it jumps back to the top and waits for the vertical refresh. So that's basic mode 0. So on we go. Basic mode 1. This might not work. No, it worked. Notice the purple at the bottom. That's your text window. And filled the screen with a weird little pattern of characters. So here we have the same 3 7-0s in a row. 70, 70, 70. 24 blank lines. Load the memory scan counter. And it's antic mode 6 instead of 1. And then the address is 9D 80. The low byte comes first. And then it just does, okay, so this was one line of mode 6. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then here's our text window. So here we have 42, which is the mode 0 in BASIC. So, and it's also loading the memory scan counter to 9F60, and then 2 and 2 and 2. So what was that? How many? I don't know. A lot of lines of 6, and then what, 4 lines? Yeah, 4 lines of 2. And then notice this address here, 7C. So we go C, D, E, F. It lines up with FF, 9DFF, when it finishes here, and then it jumps back up to the beginning. 9. See this 5E goes to 9D5E and starts over. So on to, this might not work again. It might break out of this. So on to mode 3. Yeah. Mode 3. Ta-da! Yep. So mode 3 is 8 in Antic. Or GTIA, I don't know. Antic, I think. Then 4, 8. Load memory scan counter with 9E70. And we have the address down here, 4E 9E 4E. That's the same address up here. And this 41, characteristic 41, 65 in decimal, 41 in hexadecimal. And then let's break. Let's just get a. And then what were we? Mode 4. Basic mode 4. Text window at the bottom. Mode 4 is 9. It looks like it's 5 more than basic mode right now. And of course we have the same 3 7-0s. Load the memory scan counter. Mode 9, Antic mode 9, basic mode 5. No, basic mode 4, Antic mode 9. 5 more than basic mode. 80 is the low byte, 9D is the high byte. So you can see the screen data starts immediately after the end of the display lists, because if you go start from C, D, E, F, and right after 7F comes 80, 9D. So they're trying to squeeze every byte out of this situation. And this ends every time, every basic mode ends on the last byte of the previous page. So even if the display list is huge, it does that. So let's try basic mode. What were we on? 4? Let's try 5 now. Let's try 5 now. And there's a text window at the bottom. That text window doesn't go away until you add 16 to the mode for most basic modes. Some of them are not there because they're regular text modes, but you get my point. So this was basic mode 5, and 5 plus 5 is 10, and in hexadecimal you represent the value 10 with an A. And then if we go on to 6, there's that text window. Now this is just a 2-color mode, so there's not a whole lot of memory that you need. Not like some of the not like mode 8, basic mode 8. That uses a lot of memory. So I'll show you that in a moment. But that's basic mode 6, basic mode 7. Now we got 4 colors at 160 by 80, I think, with the text window. I think it's 96 with the text window gone. So there's that. And notice I'm doing 10 bytes at a time, otherwise it wouldn't fit on the screen. So here's mode 7 in all its glory. 707070. 24 lines of black. And then, or background color, I don't know. And then 4D, load memory scan counter mode, antic mode D. At 0D90. And so however many lines that is, it's 10, 20, 30, 40, 50, 60, 70, about 80 lines. About 80 lines of mode D. And then we have 4 lines of text in the text window. Now, what I want to show you here is those 4 lines of text window can go away. You just have to add 16. So if you go 7 plus 16, 23, we're going to lose the window, the little text window, and it'll all be antic mode D. Every single line. And the addresses matter here, but not as much as mode 8. 2 scan lines of data, 2 scan lines per pixel, and 1 color clock wide. And it gives you 160 by 80. Without the text window, it would be 96, I think. Because that would be another, let's see, 4 of 8 scan lines is 32 scan lines. Divide that by what? Yeah. Something like 16 more lines of graphics if you take that mode window out. So 23, 16 more than 7, and we'll get rid of the text window. 70, 70, 70, 4D, 960, D, D, D. Alright, so what is that? That's 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96. Yep, 96 lines of 160 pixels. It's full screen mode, basic mode 7, antic mode D. So let's go on to 8. Let's do 8 plus 16, just since we know what that is now. So 8 plus 16 is 24. Full screen, high resolution, and it's really not 320 pixels. It's like it's still the same resolution, really, except that it's one scan line instead of two. It kind of does 2.5 colors according to the programmer's card. I'll show you that in a moment here. And here we've got the mode, and notice it's loading the scan counter again, and this time it's an even 9000. So 41 36 80, and you'll see that up at the top. See, up at the top you got the same address that you have at the bottom. Down here, 8036 is where the display list starts, and down here at the bottom you got your 41 in hex, 65 in decimal, and over here 36 is the low byte, 80 is the high byte, and again it lands exactly on the end of the page at FF. This is E and this is F right here. Hexadecimal. Lands right at the end of the page. And apparently it doesn't matter too much about where it starts. It just can't land anywhere but at FF. Whatever page you're coming from. So let's see, it's gonna break out of this, even if we put a number here like 7, it's gonna break. Yeah. And let's see, what I want to do is run this again, and so there's something I need to show you about mode 8. Let's review it again. Mode 8. Here's mode 8. Yeah, interpreted basic, even on an emulator. I suppose I could accelerate this. What if I did? What if I accelerated it? System. Let's see. Warp speed. Let's see what it would be like at warp speed. So if we do warp speed and we do mode, let's try mode 9 now. Oh yeah, it's quicker. Don't know why I haven't been doing this at the start. So there's mode 8, and look, see this up here, over here says 4F and not 0, and that's load the memory scan counter, and look, it's doing an even 4000 byte boundary. It had to line up on that exactly if you want all the pixels to line up on your top half and your bottom half. It has a 1024 bytes in the counter. It has 10 bytes in the counter, and that means a maximum of 1024 bytes before it'll wrap around to the beginning of the page. beginning of the memory. So you have to match that up exactly. And these aren't even amounts of data. There's like 160 pixels, 2 bits per pixel, 4 colors. So that's what? 160 divided by 8 times 2. That's 40 bytes. 40 bytes of data. So if you start at 8150 hexadecimal, I bet you if you count each of these F's and you get to this one here, it's going to line up with that. It's going to be 8FFF. It's going to be 8FFF at the end of this scan line, and then it's going to load the next one, and it's going to land right at the end of the page, and then it's going to load the scanner and just in time, and then it's going to draw the rest of the bottom half of the page. So okay, pay attention to this, because this is all 0F and 4F, 0F and 4F. So if you go to say mode 9 now, whoops. Now if we do mode, what happened here? Let's see. Oh, it's probably that acceleration. It doesn't like my typing in the accelerated mode. Let's turn warp speed off, because I might be doing something wrong. Yeah. Didn't like my typing in fast mode here. So, where were we? It's mode 9. We look at mode 9. We look at mode 9, it's also all FFF. 0F, 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 all the way down. It's going to skip in the same place. It's going to 4F, 00, 9000. So how do we get grayscale? How do we get grayscale out of the same display list? What a quandary. How about mode 10? What do we get here? Oh, lots of color. Mode 10, those new GTIA colors. How do we get GTIA color? There's a story I could tell you. I don't know if you'll believe it, but it happened when I was about 17 years old. I called Atari. I called Atari and pretended I was 17 years old. I pretended to be George in sales, and I found Atari's phone number in the back of the BASIC manual, something like that, and I was curious, how do you get more than 4 colors out of an Atari without all those hardware tricks? And so I called them, I asked them this question, and they go, we looked into this, but we don't think it's, we can't upgrade the hardware without making everything different. And I go, and they tell me, we can only get 2 bits per color clock. And I go, well, why don't you make the pixels 2 color clocks wide? They go, I think we can do that. What did you say your name was? I go, George. And they go, do you have a last name, George? And I go, in sales. And then they go, not your department, your name, your last name. And I hung up. And back then, I was only 17 years old, and I'm thinking, well, little social engineering to improve Atari. You know, I'm not going to make anything out of it, so just be anonymous. And I kind of regret pretending to be George, but that's how that story goes. It was George in sales. So that's the story of my story of how they came up with more than 4 colors without all those hardware tricks. So you had them in BASIC, like less than a year later. They came out with new machines and they had the GTIA chip in them instead of the CTIA chip. G was, I'm told, for George. So there's new mode here, mode 10, all those colors, same display list. How do they make it happen? So here's the programmer's card. I don't know if this is page 1 or page 2, but it's got your basic mode here and your antic mode here. And notice here's where that 0F and 4F come from. It's antic mode F. And it's got 320 pixels wide and 40 pixels for each 40 bytes per line. And it's got 2 colors. It's more like the text mode with 2.5 colors, but it's saying only 2 here. It should say 2.5 like those, because it's the same sort of thing. And then it's 40 bytes per line and half a color clock wide. That's where the 2.5 comes from. It's only half a color clock wide, so it does an artifact between blue, real light blue, and then it's got kind of a green or a brown color on the Atari. And then look at the amount of memory that it's using. 7,680 bytes per screen of this data. And Mode E's got the same deal, but it's only 160 pixels wide. So and it's only got 4 colors. But we're getting something like 8, 9, 10 colors out of these GTIA modes. And the secret is down here in the hardware registers. Bit assignments for selected hardware registers. So you have down here in prior the GTIA mode selection, 2 bits. So you got 4 new modes in that GTIA chip that allow you to do more than 4 colors in 2 color clocks wide, 1 scan line high, and it's like 4 times wider than it is high. But found lots of demo. The demo scene went wild with that GTIA color modes. Lots of color. So there you have it.